In this video, we're going to be introducing exponential functions. So an exponential function is a function here, f of x equal a to the x. This is different than functions we've been doing because you'll see that the variable is in the exponent. Previously, in our polynomial functions, we would have our exponent here. We would have our variable here, and then we would have it raised to like a 2 or 3 or a 4. In these exponential functions, this a is going to be a number like 2, 3, or 4, and the variable is going to be the exponent. So the easiest way to graph these functions, which is something that you will do in this lesson, is to use a graphing utility like a graphing calculator or a website. Desmos.com is one that I use. So I'm going to take you there. And here, when you come to the first page of Desmos.com, you'll see that graphing calculator option right there at the top. So to graph these, we could consider an exponential function like f of x equal 2 to the x. That would be an exponential function. The way we would graph that is 2, and then you would use this a to the b button that lets you choose what you want your exponent to be. In this case, it would be x. So you can see that these graphs are almost always going to cover half of the coordinate plane, and they're going to curve very steeply up. So this is a very simple exponential function. You could have a more complex one like 2 to the x plus 1. And in that case, to graph that, you just would have to make sure that when you put your 2 in, you use the same a to the b button, but now our exponent is going to have to be in parentheses, and we could do x plus 1, close parentheses. And so that just shifted our graph up a little. And you should be able to graph any of the functions using a graphing utility like this one. Okay, so let's go back and talk a little bit about the properties of these exponential functions. So the first property that we want to talk about is called the one-to-one property. Now, if you remember when we introduced functions, any function, they have a one-to-one property. What that means is that for every x, there's a single specific y that makes that statement true. So the one-to-one property here, what that lets us do is that if we have two equations, a to the x equal a to the y, that can only be true if and only if x equals y. Okay? So that probably seems pretty obvious, but what that allows us to do is solve equations with exponents. So for example, if I have 9 equal 3 to the x plus 1, what this property tells me is that if I can get my bases, the numbers here, exactly the same, then I can set the exponents equal. So you're going to have to use some of your exponent rules in this lesson, which hopefully you remember. And you're going to have to notice when you can turn a number into another number using exponents. So for example, in this case, the 3 is a prime number. So we really can't change it into a different number with exponents, but 9 is not. Hopefully you recognize that 9 can be written as 3 squared, and this 3 on the right gives us the clue to use a 3 on the left, and then we would leave the right exactly the same. Well, now because my two bases are 3's, they are the same, that means that I can set the exponents equal to each other. They have to be equal. And now we have a simple equation that we can solve by subtracting 1 from both sides. And we'll get not -1, but 1 equals... get 1 equals x. Okay, let's try a little more complicated one. So now let's take 1/2 to the x equals 8. Okay, So again, we have to get these two sides to the same base. So hopefully you notice we have a 2 here. Well, 8 could be written as 2 to a power, right? We could write it as 2 cubed. And then that gives us 1/2 x. So they're almost to the same, but not quite. We have a 2, we have a 1/2. So here's where you have to remember some of your properties of exponents. So if you remember, one thing that we learned is negative exponents. So if I have 1/2 to the -2, remember that that negative just can be moved to the top and it becomes positive. So I could move that to the top and I would get 2 positive 2. The reverse is also true. If I have 2 to the -2, I can move that to the bottom of a fraction to make it positive 1/2 squared. So in this case, if I want to eliminate the fraction on the left so that I have 2 as a base, I can do that by moving this 2 to the top of the fraction and making it negative. So this becomes 2 to the -1x equals 2 cubed. Then if you remember that the exponent rule for a power raised to another power means that we multiply those. This becomes 2 to the -x equals 2 cubed. Now I have the same base. I have a 2 here and I have a 2 here. So I can set my exponents equal to each other. I get -x equals 3 or x equals -3. All right. Clear some of this off, and then we're going to take a look at a specific exponential function. It's a common exponential function known as the natural exponential. So the common exponential function comes up a lot in when you're looking at population growth, when you're looking at interest, and we're going to look specifically at that one. And it is the function f of x equal e to the x, where e is an irrational number. Well, it's approximately 2.71828, and it keeps going. So it's like pi. It is a number. It's a specific number, but the decimal part of it never ends. That's what an irrational number is, right? But this specific number, 2.71828, and so forth, actually reoccurs in natural problems that we see a lot. And so it's been given this name E, just like pi, has been given that symbol to represent 3.146 and so on. Okay, so we're going to use this function to solve, we're going to look at some interest problems, and this number will come up in those interest problems. So compounding interest problems are, they have to do with how often interest is applied to an account, right? So you can have interest that compounds yearly. That means if you have money in an account, at the end of the year, you get interest once a year. Interest can be compounded monthly, so then you would get interest every month, and your interest would start earning interest, right? They deposit the interest into your account on whatever the compounding period is, and then you're earning interest not only on your deposit but also on the interest that was put in there. So obviously the more compoundings you get on an account, the more money you will make more quickly. So the formula for looking at these problems is A equals P times 1 plus R over N T. And in this formula, A is the account balance. It's how much you put in the account to start with. P would be the principal. R is the annual interest rate. And it must be a decimal. So do not forget that when you are given a percentage, it must be converted to a decimal. T is the number of years. And N is the number of compoundings. A note on the number of years, the t value, make sure that you are using number of years. So for example, if you have a problem where it says 6 months, that's only half a year. So the number that you would use in the problem would be 1/2, not 6. Not the number of months, but the number of years. And then n is the number of compoundings. Okay, so I'm going to read a problem to you and we're going to pick these things out, and then we're going to talk about what it would look like to compound interest quarterly, monthly, and continuous. So we are going to invest $12,000 at an annual rate of 3%. And then we want to find the balance after 5 years for each type of compounding. Okay, so if we invest $12,000, that means that our A is $12,000. Right? That's how much we put in the account at the beginning. You invest $12,000 at an annual rate of 3%. So my rate is 3%, but that must be converted to a decimal, which means I move the decimal 2 places to the left, so that becomes 0.03. Find the balance after 5 years. So that means that my t, my number of years, is 5 for each type of compounding. And we're going to do quarterly. So I'll just put my n's over here. We want to do n quarterly. So that would mean the n would be 4. Quarterly means 4 times a year. We want to do one for n monthly. So in that case, n would be 12. And then we want to do continuous. And what happens with continuous is you get a completely different formula. So we'll talk about this one a little bit separately. If you look in your text for this course, it will show you how to convert this equation into a continuous compounding equation, but you're not required to be able to do that. You just need to be able to apply the equations that are used. Okay, so we take our formula and we plug in our given numbers. A is 12, I'm sorry, A is not 12,000. A is what we want to find. P is 12,000, the principal, the amount we put in. The account balance is what we're looking for. So A, P is 12,000. 1 plus R was 0.03. And N is 5. And that's raised to the NT power. So that's N times T. In this case, our N is 4. And our t is still 5. Okay, so for quarterly compoundings, we now simplify the right side of this equation. If you simplify inside the parentheses first, you'll get 1.0075, and then 4 times 5 is 20. And then you can just use a calculator to multiply all of that out, and you should get 13,934.21 cents. So that is how much you would have if you had quarterly compoundings. So I would probably suggest, if you're not comfortable putting these type of exponential problems in your calculator, working this one out to make sure that you're putting things in the right order. If you have a graphing calculator, it's pretty straightforward. You type it in just like you write it. But if you're using a smaller calculator, it's not a graphing calculator, you do have to put things in the right order. Okay, now let's look at monthly compoundings. So the only thing that's changing is our n. Everything else is the same. A is equal to 12,000 times 1 plus 0.03, and now it's over 12. I'm goofed over here too. This should be a 4. Very sorry about that. I hope I said 4, but I wrote 5 because it's n. It's quarterly. It's 4. Okay. 1 plus 0.03 over 12. And then it's 12 times 5. 5 years, 12 compoundings. So if we simplify that, you should get 1.0025 in the parentheses, and then 12 times 5 is 60. And if you simplify that out, you'll get $13,939.40. okay? So you can see that from quarterly compoundings to monthly, the amount went up a little bit, right? Now let's do continuous. Continuous means that you are constantly earning interest and gaining interest on your interest. So I'm going to show you the formula for that. So what happens when you do that is you get this new formula, A equals P E R T. So the formula changes. This is for in compoundings. This is for continuous compoundings. So here our principal is still the same. We've still invested $12,000. Remember that E is a number, R is 0.03, and T is 5. Okay? So you just plug this in and get an answer. You can use Desmos.com where you would graph these type of functions. You can use your graph calculator. Almost all calculators have a E button that will give you the number, just like pi. And if you put that in, what you should get, well, if we simplify the exponent, you're going to have 12,000 E, and then you multiply 0.3 times 5 to get 0.15. And then you will end up with $13,942.01. So again, definitely more than the smaller compoundings.